ಹಾ Greetings from
Welcome everyone. Thank you for joining us for today's webinar. My name is Akshay Kumari, Research Scholar, Department of Electronics, Mangalore University. We are provided the YouTube live stream link to join international webinar on nanomaterials and flexible electronics. Now we will move to the second invited talk of this session. Dr. B. Hemakumar will deliver this talk. He is also there here. Dr. Yes, B. Hemakumar is an assistant professor from Department of Electronics and Instrumentation Engineering, Puducherry Technological University, formerly known as Pondicherry Engineering College, India. He obtained his PhD in biomedical image processing from Pondicherry University in 2017. He has published papers in 20 international journals and conferences. He has trained more than 700 teachers on the usage of ICT tools for education and delivered over 25 technical cum practical workshops to students all over India. His research interests include medical image processing, biosignal processing, medical instrumentation, design and education research. So once again, dear participants, if you have any queries and questions, if you put it into the chat box in your YouTube control panel. Now I request Professor Naveen Kumar SK to continue the session chair.
Welcome, Dr. M. Kumar.
Yes, sir. Good morning. Good afternoon.
And the session of biosensors and Internet of Things in wearable health application, healthcare application. I think this is the boom field and advanced field. I think this your talk may be helpful for the young researchers and those wanted to carry research on flexible electronics using IoT related things.
Yes.
So over to you.
Thank you, sir. A very good afternoon, almost good morning, okay, to one and all present over here. It's a great opportunity to be among you people on this day. So I'm going to just, I'm basically a signal specialist, okay, who work with the signals, who make, extract useful information from the signals, transmit those signals. That's the kind of work that normally we do, okay. I'm myself Dr. B. Kumar from Puducherry Technological University. Thanks Akshay and Naveen sir for giving the introduction. So basically this field, as you told, it's a kind of booming field where we have a lot of wearable devices nowadays used, okay. So these wearable devices will be very much, it is actually benefiting the customers, the users, as well as because of the advent of biosensors and the IoT technologies, the amalgamation of these two, it has gone to greater heights, okay, these kind of technologies, okay. So all of you might be using MI phone, MI watch. I'm actually personally using an MI watch, okay, MI mobile device, okay. So which actually monitors my heart rate, my pulse. It also gives me my sleep patterns, okay. So that's the kind of technology. Now we try to interact with the internet, okay. That's the purpose of this particular interaction. So coming to the learning outcomes, so I'll be just interacting with you about the overview of the challenges in wearable sensors, okay. So what are the wearable sensors and what are the challenges that are available? And particularly we are going to see about the technology behind a smart bandage system, how it is implemented, okay, the technology. And being a signal specialist, I concentrate more on how to extract the signal and how to make the signal usable, how to interpret the signal. So that is my area of domain, okay. So I'm also exploring some case studies on IoT based wearable technologies. And I'm also going to show you a small demonstration how to do a data sharing, because the current trend for wearable devices is the wearable devices should communicate with the cloud, a data sharing between the cloud and the IoT devices. How the data sharing is taking place, we're going to see a simple demonstration, okay. So that's how my today's interaction is oriented towards. Okay, so first we'll see overview of the IoT system. So this is the top area of the current market. So it's IoT device using for the healthcare. IoT is particularly for healthcare. If you happen to see the healthcare IoT, particularly we have good number of sensors, okay, which acquire the data from the users. Okay, the patients, they acquire the data, and these actually they can be smart sensors, as Pramod sir mentioned in the previous talk about the usage of carbon nanotubes. We have a good number of sensors that are actually fabricated with carbon nanotube and silver gel materials. Okay, so these data acquired from the patient will give you the detail about the patients. It may be a sleep, it may be a heart rate, it may be a pulse, it may be saturation level of oxygen. Okay, all these data are fed into the cloud. Okay, from the cloud we do the processing of the data, extract useful information from the signal like signatures. We will be extracting a lot of data analysis. Okay, and ultimately the information will also give it to the physicians. Okay, the physicians will be helpful in making up the system. They will be identifying what are the anomalies, what are the arrhythmias, what will be the problems. Based on that, they will be able to provide a solution. Also, we'll give a benefit to the users and caregivers who are acknowledged with the status of the particular vital parameters, or what is the state. Okay, that's how this healthcare IoT works. Okay, now we're going to see a small interaction. Actually, I can see all the participants I can see all of them from the YouTube. I just want you to interact with me. I'm just presenting you. So all of us are using wearable technologies. All of us are very much fond of these wearable technologies. According to you, what are the challenges in the wearable technologies? So for this, I want you people to log in into a website called menti.com. I have given a code on the top, 8595594. I have given a code on the top, 8595594. Use the code to give your answers. So I want to know we'll be using wearable technologies. Okay, watches, okay, Fitbits, lot of wearable technologies we are already using, but they don't have an interaction with IoT. Okay, now I'm asking you, what are the typical challenges when we go for these wearable technologies? What you looking for? Okay, so I want you people to look in this particular menti.com. Just give your views, 8595594. I just want you to type in this particular code. I'll just type it in your chat window also. Okay, I can't type it. So just, if you can, just type in this code. Can you interact with me? Is it possible? Akshay, can you just transfer this code to the participants? Tell them to go into menti.com and use the code.
Okay, sir.
Please. Yeah. Please, you can start giving your answers. What do you think as the typical challenges in the wearable technologies? At least I expect a single answer. You can just log in into this particular domain and you can give your view. What do you think is the challenge? When you go for a wearable technology, what is that you look for? What are the typical challenges in wearable technologies? Okay, we have one answer here. The good thing about this Menti is you not know that who is answering, but we'll just know what are the things. Okay, miniaturization, good. Power consumption, Okay, there are a lot more factors. We'll just discuss some of the factors that are critically important. Okay. So the typical challenges, as you told, is low cost technology. Definitely, cost is a very, very important factor. Okay, battery life, excellent. Okay, we have bio-friendly material, good, excellent. Bio-resistance, miniaturization, flexibility. Of course, flexibility is very much required. Okay, so battery life is also another concern. Okay, so these are all different views. Okay, excellent. Thank you friends for giving your views. I can see more people are bio resistance. Okay, excellent. Bio friendly material. Okay, good. Okay, so that's the kind of thing I require. Okay, we have still more answers. Privacy, excellent point. Biocompatibility, good. Time delay, fine. Okay. Costly, it's excellent. Costly, factor of the cost. Not trustworthy, exactly. How much trustworthy? How much we can trust upon these devices? Fine. Okay. Thank you, friends. You can still give your views. I'll just come back to this. So the first and foremost is the low cost. So as far as low cost is concerned, there are many factors that actually come into this cost. One is about the sensor and what is the kind of sensor that is used, what is the power consumption of the sensor. Okay, so all these factors come inside your low cost technology. Second thing is interoperability and expandability. That's what many people have told about flexibility. Okay, so interoperability is actually about it should be suited for a variety of platforms. Suppose normally we use this MI band, so which can communicate with your mobile device. Okay, so it is a small range via Bluetooth. When we talk about interoperability, it can be over a wide platform. It can be via Zigbee, it can be a HTTP protocol, it can be via your internet. Okay, it should be operable over the thing. So currently, most of the devices that have been developed, they are very specific. They are very specific to that particular area or application specific. Okay, we need to explore of expanding this one and expandability of the solution. It is like we don't normally purchase a device which is suited only for one particular application. Suppose they sell the same MI watch only for heart rate and sleep pattern. Less people will buy the product. Okay, so I'm seeing more answers. Safety, security. Okay, thank you. So but what happens is that this device is also coupled with a mobile phone wherein I can receive calls and the function. So it is, as far as people buy a product, it depends upon multiple functions. So expandability of the overall solution. Okay, so instead of serving as a single point, you need to expand it. Okay, that's the second factor. Well said. Third factor, as you all know, you get abundant data. Okay, the data that you get from the system is going to be abundant. Okay, how we are going to process this information? Okay, how to process this information and come out with some useful information? For that, you require a machine learning algorithms. So these factors, these are also factors which is a really challenging part of the thing. And last factor, as everyone has mentioned, the security factor. How far my data is secure? Okay, when I share my personal data, how far it is secure? Okay, normally whenever we go for sharing of medical data, it has to be it has to be under strict privacy protocols, and it should be with the consent of the user. It should be with the consent of the user. The data has to be shared. Okay, so these are all some of the typical challenges for wearable sensors. Okay, so here I'm actually giving you certain examples where we're going to talk about. Okay, you can see this girl with helmet kind of thing. Can you tell what is this thing? Can you guess what is this? You can type in your chat window. what is the kind of device it's actually. What's the type? Okay, size and weight. Many have mentioned in the comment itself. Okay. So I'm asking you, okay, fine. So this is a kind of helmet. This is a kind of helmet. If you actually see, it actually identifies the mood. If the person is in a depression kind of thing, it will be able to regenerate the person. That's the kind of, so see the technology that is going, that is to aid the personal, and it is going to be give a personal experience. Okay. And the thing that we are going to see today is this particular interesting factor. It's called as a smart bandage. Okay. Something, okay, everyone know what's a bandage, right? So whenever we have a wound or something, we are going to use a bandage. Okay. So what is the purpose of the bandage? The bandage serves the purpose like it is going to okay. So the bandage, basically, if you have your bandage, it's going to prevent the wound from spreading. Okay. And it serves as a barrier. Okay. And most common problem with our bandage is, at particular, even though the wound is a very big one, after the wound is getting healed, okay, that particular region will have that sensation of itching. That will be a very, very difficult phase to cross. Okay. Now we are going to talk about a smart bandage. So smart bandage is something which is a wearable, which is not going to cause any difficulty, and it is going to monitor the status of the wound. It is going to give you real-time updates, and the drug delivery is also via a diffusion process. Okay, that's the interesting thing about the smart bandage. So these are the components of the smart bandage. Okay, it has a temperature sensor, which is going to sense the temperature from the person. It has a drug delivery pump. Although this is a drug delivery pump, it is a manual pump. It's a manual pump which is going to act, and whenever you give a pressure, it is going to release a drug, but the mechanism by which it is released is called as drug diffusion method. It is by a drug diffusion method it is released. Okay, you have a touch sensor which is going to which actually serves for the input. Okay, whenever you give an input, whenever you press it, that will be reactivated. Okay, that will actually reactivate your functioning. And you have a wireless coil. The coil actually serves two purposes. One is for powering up, and second one is for transmitting the signal. It is either for powering as well as transmitting the signal. It is twofold purpose. Okay, so that's how the components of the smart bandage. So coming to the temperature sensor, as Pramod sir told, it is using a carbon nanotube ink, mainly for whenever you have medical applications. The most preferred material for your recording of biosignals will be a silver material. Okay, so this carbon nanotube is mixed with signal, silver. That is the most prominent type of sensor, and this is basically a sensor. As Sir told, it is using P.PSS. Okay, it is P.PSS. Actually, the technology of P.PSS actually amazes me. Okay, that is conductive plastics. It's a category of conductive plastics where we use by the technology of electron hopping. You might be knowing what is an electron hopping. So using that, we are having conductive plastics. So these two are mixed, carbon nanotube ink and a silver ink or gel are mixed together, and they are cured for 70 degrees centigrade, and it is used. Okay, so particularly this is a printed temperature sensor. You can see this is a shadow printing of a temperature sensor, and it is having on the PDOT. Okay, so it offers a good sensitivity of minus around 0.78% per degree centigrade. Okay, and the resolution, and also to detect a change in the temperature, that is via illness. Whenever you want to detect an illness, it is around the temperature resolution should be at least 0.01 degrees centigrade to identify this. Okay, that's the kind of temperature sensor that is employed. Also, we have a heart rate sensor. This is an heart rate sensor. Again, this is using CNT and silver nanoparticles. Okay, with the ratio of 5:3 weight ratio. So basically, it's a strain sensor. So strain is nothing but a force. Okay, force or a pressure. Okay. So here we use a mechanism for resistance. Okay. Basically, you can think of a strain as a wire. So whenever it will be so sensitive to the heartbeats, whenever it senses the heartbeat, it undergoes flexion. Okay, that will actually change its resistance. This will be used as a strain sensor for heartbeat measurement. Okay, and the third mechanism that actually interests me a lot is wireless detection. Okay, so see this kind of wireless detection that is used in these devices. You have two coils actually. So one is a transmitting coil and a receiving coil. You can see the circuit here. Okay, you have a capacitance connected in series with the two coils. So whenever a person touches on the capacitance, whenever he touches, the capacitance and the inductance changes. Okay, the change is actually is reflected as a frequency change. When your capacitance and your inductance change, it is a frequency change. This frequency change, it's going to actually, in terms of frequency change, we can tell it as resonant frequency change. It's more dominant around 42 megahertz. There will be a resonant frequency change and amplitude change. That will be detected as a change that will be transmitted outside. Okay, so that's how your wireless detection serves its purpose. It actually backs up the power supply required for the operation as well as for the transmission purpose. Fine. And the last part of that thing is a drug delivery. Okay, so you have a small reservoir of that particular drug. So whenever you press it, it just goes in via a diffusion mechanism. It's a diffusion drug. Okay. When I actually remember this diffusion drug, initially it has been used for the most popular diffusion kind of thing is for drug delivery, mainly for insulin. Okay, insulin for patient delivery with insulin. We use this kind of okay, excellent. Many have I have not seen the chat window. Sorry. So mood analysis, emotion recognition. Thank you, friends Sachin and Pratima Bhatt. Okay, fine. Back to the thing. So insulin for drug delivery for diabetes patients. Okay. So basically, it is fabricated out of elastomer of polydimethyl siloxane. Okay. Typically, if you see a normal gentle human touch, will be around 3.3 kilopascals. The pressure is around 3.3 kilopascal for a gentle normal touch. Okay. So this touch will actually infuse the drug into the patient via diffusion mechanism. Okay. So this is all about the components of your system. So this is a typical response that you get from that sensor, temperature sensor. You can see this. Actually, we are recorded for two cases. This is the first case and this is the second case. First case is when the person is taking a spicy soup. We all know that what happens when you take a spicy soup. To compensate for the temperature, body automatically increases its temperature. Okay, so you can see the slight elevation, the temperature around 33 degrees centigrade. Okay, so that's the case for when a person takes up a spicy soup. Okay, and this is a person exercising. This is for a short duration of 12 minutes, recorded for 12 minutes. Here there is not appreciable increase in the temperature. Okay, so this is the response of the sensor, temperature sensor and touch sensor that we get from these kind of smart bandage systems. Fine. So far we have seen about the interaction. Okay. Apart from these, we have seen as far as the smart bandage is concerned, we looked into a temperature measurement. We looked into a heartbeat measurement. We saw about drug delivery. Okay. These are and apart from this, you have good amount of wearable sensor that are currently in use. Okay, so this is we have seen already heart rate, and we have blood pressure, blood glucose. Okay, just for knowing, can you tell what is the blood pressure of human beings? I just want to type it into the chat window. What is the temperature sensitivity per degree change? What is the percentage change for a degree centigrade temperature? That's called as sensitivity. How far my device is sensitive? That's called as temperature sensitivity. So our normal blood pressure is 120/80. Okay. So you have the respiration rate, oxygen saturation, temperature, skin. These are some of the parameters and the type of sensor that are used for recording these devices. Okay. Mostly I will be discussing about macro scale sensors. Okay. Okay. Now I'm going to present a very interesting technology. That is this ICT. That is usage of IoT tools, particularly for elderly people, particularly for elderly infants. Okay, so we're going to see some simple case studies. We'll see just. Okay, I'm having an interesting statistics from LPage International. It's an international organization for NGO for welfare of the elderly. These are the health challenges. So elderly, older people and infants. Elderly, older people and infants. They have a very interesting statistics that by 2050, nearly 1 in 5 people in developing countries will be over the age of 60. Okay, but this is a very interesting statistic. By 2050, nearly 1 in 5 people in developing countries. So you can think of more number of aged people. Okay, over the age of 60. Okay, now, so whenever there's an old age, okay, they will be experiencing a lot of challenges. Okay, so I want you to type in what are the challenges typically faced by elderly people. Okay, thank you Sasidhar and Pratima Bhatt for giving the blood pressure ranges. Okay, so I want you go back to the same Menti. I want you to go back to the same menti.com with the same code. Use the thing. I want you to type in, there are typical health challenges that are given. I want you to rate the health challenges. What are the health challenges that are presented over there? I need you to rate it. Okay, I need you to rate the health challenge. Okay, you will be able to see it. I'm just showing the menti.com. Okay, so use the same code. And try to get these details. So I want you to rate the following health challenges that affect the elderly people. Rate the health challenges that affect the elderly people. Okay, sorry. Good. Okay, so as per this, so our 4 members have given their views. So first is hearing loss, then we have mental health issues, third is cardiovascular diseases, fourth is balance disorders, Okay. Okay. So the thing changes actually. So hearing loss, cardiovascular. Okay. So first, cardiovascular disorders come into picture. Good. Hearing loss. Excellent. Balance disorders, mental health issues, cognitive impairments. Okay. Okay. So as per the rating of now of 11 members, so cardiovascular, so okay, 12 members. So the peak is cardiovascular diseases. Second one is the hearing loss. Third is the balance disorders. Fourth one is the mental health issues and cognitive impairments. Okay. So we'll come back. I'm just going to show the statistics from LPH International. Okay. Fine. So this is the order in which they have given. Okay. So the first is hearing loss. As per the statistics from LPage International, the most common and the most top one is the hearing loss. Okay. Hearing loss accounts to nearly, particularly in the age group of, just take a pen. Okay. So particularly in the age group of 65 to 74, 1/3 of the person will have the hearing loss, and above 75 age, 1/2 of the person will have hearing loss. Okay, so that is the severity of this particular problem. Okay, so whenever a person has hearing loss, so will not be able to get well with particular kind of social environment. Okay, and which actually will cause some kind of social isolation. But nowadays, good technologies for hearing loss, smart devices are coming into picture. Okay, so the first among, as per the LPH International, it is hearing loss. The second one is cardiovascular diseases. So actually, as per the 2016 statistics from WHO, roughly around 31% of the death are caused due to cardiovascular diseases. Of that 31%, 85% are mainly due to ischemic heart disease. Okay, that is the statistics. So cardiovascular diseases pose a very big threat. Then you have cognitive impairments. So cognitive impairments is about the ability to hear, speak, think. Okay, so these abilities also lower down as you age. Okay, so cognitive impairments. Then fourth one is mental health issues. Okay, that's about depression, anxiety. Okay, so that's mental health issues. And lastly, balance disorders. So the ability to walk. Okay, the sensory motor system, how much they're able to respond. Okay, so this is the statistics as per thing. Okay, from our experience, it actually changes from what we have experienced. Okay, fine. So I'm going to see two technologies available here which covers most of these one, particularly first for elderly people. Elderly people, we have this particular kind of thing. It's a IoT based monitoring system. It's called a smart beer. It's called a smart beer. It is a smart living solution platform for the elderly people. It's a smart solution for the elderly people. Okay. So particularly what they tell is that you can just log in into this website and see about this project. It's an ongoing project, Smart Beer. It is actually pioneered in 5 cities, Rome and different Greece. Okay. So they actually address hearing loss, cardiovascular diseases, okay, and all the mental health, all the 5 problems they address. So basically what it has is, so this is the architecture of your smart beer. You can see we have the patients here. On this end, we have the patients, and these are the caregivers and significant others. So caregivers can be the family members or the organization who take care of the patients. Okay, so they can communicate. So you have a good amount of patient devices. Okay, starting from simple temperature sensing, heart rate sensing, hearing sensing. You have different devices. Similarly, you have smart home devices. Okay, all these contribute towards a smart beer home hub. We have a hub, okay, which is going to amalgamate all the information from the devices. Okay, these are then transmitted to the cloud. So you have a smart beer cloud. Okay, this smart beer cloud collects the data from your real-time sensors, and from the system, from the hub, it collects the data. And the very beauty about this particular cloud is it has a good amount of data analytics. Okay, so based on the information from the caregivers, based on the information from the patients, it will be delivering personalized interventions. It will be able to give personalized intervention to the users. That is the advantage. Okay, by using machine learning algorithms, it will be able to give a personalized intervention. Also, it is going to be associated with the hospitals. Okay, so which has the expertise knowledge of the clinicians, thereby it will be helping the patients to overcome these kind of difficulties. Okay, it will monitor the status, it will serve as a companion, it will give them real-time visualization of the thing. So it will be giving sufficient alarms and warnings to the caregivers about the status of the patients. Okay, so that's the kind of system that is smart beer. Actually, this smart beer is built on Evotion platform. You can just see this particular website, h2020evotion.eu. Actually, currently it is being used for 5 hospitals in Greece. Actually, this is using this particular Evotion platform. Okay, where they collect a good amount of medical, physiological, and lifestyle data from heterogeneous resources, sensors, and based on that, they provide personal interventions for these patients. Okay, and currently the project is being tested and validated through 6 different countries. Okay, France, Greece, Italy, Spain, Romania, and Portugal. Okay, so these are the, you can just go into the website of the smart beer. Okay, and you can explore more about this project. And they have a special smart beer consortium. There also they have a discussion kind of thing. Fine. And the second interesting application for IoT we're going to see is called as xVLEPSIS. Okay, it's an intelligent, invasive, non-invasive biosignal recording system for infants. Okay, so this particular project is mainly for detecting the infants. So normally babies will have a lot of problems. To monitor the status of the babies, they use this kind of smart bed mattress. Basically, the smart bed mattress, it contains a high resolution video camera. So high resolution video camera to monitor the baby. It also has an audio recording, high quality microphone to record. It has an ballistocardiogram to record the heart rate and other parameters, ECG related to conditions. Okay, it also has a temperature and humidity sensors. Okay, humidity sensor which monitor the patient's sleep. Okay, the most problematic whenever for a pediatrician is they have to interpret something only based on the doctors, the patients, that is the parents' input. They can only respond based on the parents' input. Okay. Here we are trying to see a system wherein the doctors can get more information about the babies without disturbing their sleep. Okay. So even this device, this particular system, as an mobile device wherein the parents will be alerted with specific conditions about the patient. Okay. This is a entirely system that is governed with infants. This is a system that is governed with infants. Okay. Now we'll go into the interesting part of our session. We're going to see a simple demo. Okay. So this is a system. This is a system. This is how your wearable technologies communicate. Wearable technologies communicate with the IoT or the cloud. With the cloud. Okay. So these are the different devices by which you can obtain the data. Either you can use a Arduino or a data acquisition device. Okay. So here we are going to tell about this platform, LabVIEW, and actually I'm going to concentrate only on this region. So after the sensor data is there, how to use your LabVIEW. LabVIEW is a software which you can use it for visualization. You can go for deployment stage, up to a deployment stage. We are going to communicate the data to a cloud. Okay. So via HTTP protocol, we are going to communicate the data to the Firebase cloud. Firebase is a Google cloud. Firebase is a Google cloud. We're going to show you how to use the Google cloud and how to share the data with the cloud and how to receive the data. Okay. Again, this is, you can use it along with MIT App Inventor also, which I'm not going to show you. And see the format of data. The format of the data is JSON. JSON is a format. It's a string type of data. Okay. That's the data format that we are going to use to transmit data. We'll see it now. Okay. I'm just going to show you. Okay. So I'm going to use LabVIEW. So before I use LabVIEW, I'm just going to take you into the cloud system. So this is the Firebase cloud. It's a Google cloud. It's a Firebase Google cloud. You need to log in with your account. With your Google account, you can log in. I'm just going to the console. This is a Firebase console. Already I have created a project. We can create a new project. So here you have your Firebase projects. I'm creating a new project. So I just do today's webinar. I just put it as webinar. Some name for the data. Okay. I'm just giving a name for the data project. Okay. So I'm just creating a small project. Okay. So a project is getting created. It will take a few seconds depending upon our it will take a few seconds to create that particular thing. In the time, I'll just open up LabVIEW. So this is a LabVIEW. Okay, I've already created it, but let me explain you what are the things that are available. Actually, I'm going for data communication. So when I right click, so in your LabVIEW, you have two panels. One is a front panel and another one is a block diagram. To put it simple, front panel is like the front of your instrument. You take any instrument for your recording. So the front panel is something like the front of the instrument. Block diagram is like the internal part of your working. Suppose you to say a very simple one, addition of two numbers. So your front panel will display only the addition part, the display the two input numbers. The internal block diagram will tell you about how it all joins together. Okay. So here I'm going to use a protocol called HTTP. So that when I right click, I have data communication. Under protocols, I choose HTTP client. Okay, so this is the protocol I'm going to use it. I'll use HTTP protocol. Okay. So this is the protocol I'm going to use. So whenever I want to initiate the response, I have to use open handle. I have to use open handle. That will be actually initiating our mechanism. To send a data into the cloud, you have to use the command put. Okay, the command to be used is put. You can see in put, you need to give the URL where you send the data. Then you need to give the input data. Okay, input data. This is a converter. This will actually convert your data to JSON, and you have a close handler. I'm just having a while loop for this control, a simple while loop. Okay, now we need to go back to the Firebase. Okay, the Firebase is started now. Now I'll just go to see on the develop side, I have real-time database. I'll just go to the real-time database. So I'm just want to create a new database. So I'll create a new database. There are two modes in which you can create a database. You have lock mode and test mode. Lock mode is more private. Okay, so I go for test mode just for checking it is public data. When I move in test mode, it is public. I go in test mode. So this is the address of my thing. Okay, this address I need to copy it. This address I'll just copy it. This is my cloud address. Okay, so I'll come back to my cloud, my thing. Here you have this address. Okay, I'll just paste the address that I have copied there. So it is a webinar, and it has to be data in JSON. Okay, data.json. Because what I do is that this is a cluster. Cluster is basically a mixture of different datas. So this is say arithmetic data. This is say Boolean data. This is say string data. Mixture of these three is called as a cluster. Okay, I'm trying to add some data. Say I'll just add a sensor value of say 67. I'm giving a Boolean data. So some calibration data, E1, 2, 3 something. Okay. Now I want to transmit this data to the cloud. So, okay. Now we can see the data is in the real time. Whatever data I have sent. Okay. You can see the data that I have sent from this particular platform. Okay, you can see the data here also. The data handling is also shown here. The same data is getting transmitted to your cloud. You can see this is a simple application I'm showing. It's a public cloud, public data. I'm showing a public data. Okay, so anyone can use this address and access this data. Okay, this is how you use a simple cloud for sending the data from your. So this can be any data. So I'm just showing it for a simple cluster. You can use it for any data, physical data that you have. Okay, suppose you take any signal. Once you extract the useful parameters from the signal, it is going to be a series of numbers. Okay, that series of data can be sent to the cloud. Okay, so this is how you send the data to the cloud. I'll just show you how to receive the data from the cloud. Just a opposite of this. I'm just going to open the receive part. So in receive part, you can see the same thing. Instead of put, I'm going to use get. Instead of put, it is get. Okay. So I need to change the address. I need to change the address where I'm going to retrieve the data. Okay. So it will be in JSON format. I'll just convert the JSON data cluster data, and I'll be presenting the data on the PC here. Okay, so I'll just run. You should be able to see the sensor value, and okay, so that's the data that is retrieved from the cloud. You can see the data. So the Boolean status, the calibration data, I can change the value from here. Say I'll just give 6, 7 or some other data, 375. Okay, I give IE. Okay, I have to press enter to change the data. Okay, so now it should be reflecting on your mobile PC. Okay, so that's how you can simply transmit data via the cloud, communication via the cloud. Okay, I'm just demonstrating only the LabVIEW part. From the LabVIEW, I'm sending the data to the cloud. The second example, I just received the data from the cloud and displayed. Okay, so the processing part, suppose you can do it in the cloud itself, or you can do it in your system from the remote end. Okay, so this is how we can exchange data via the cloud by using this software platform called LabVIEW. Okay, so back to the presentation. Okay, so the last part of our session, it's about how to use these kind of wearable tech for COVID-19, particularly for COVID-19. Okay, so these are some of the current wearable techs in market. Many people might be using it. Okay, one is the most popular Fitbit. Fitbit is, it has basically respiration rate, heart rate sensing. Okay, and the one that is new, this is GoQI. GoQI is also having a SpO2 measurement, oxygen saturation measurement. Then you have Cora Ring, which is also now into COVID-19 identifying the phenomenon. So basically, Cora Ring is for sleep pattern studies. It is basically for sleep pattern study. Currently, they are also focusing on the kind of health monitoring for COVID-19. And this is Apple Watch. All of you know about Apple Watch. The interesting thing about in COVID-19 is that they have introduced a wash detection system and wash detection system. There will be a preset timer for 20 seconds. It will detect your motion, whether you are washing your hand perfectly or not. Okay, that's an Apple Watch which does the job. And these are all other sensors in the similar field. You have Biosensors wearable sensor, which records your ECG and other vital parameters, and jawbone UP sensor is similar to that of your Fitbit. Okay, these are some of the sensors which claim to combat COVID-19 by identifying the initial things. Okay. Okay. So to conclude, so the role of the smart biosensors and IoT is significant in the modern medical system. Okay, it provides the patients, care providers, okay, the health professionals, doctors to come at a better conclusion and provide good personal interventions. Okay, because of these kind of systems. And mostly when we talk about flexible and wearable systems, they should be more macro scalable, and mainly it should be economically available because of the fabrication technology that is available. Okay, so the cost should be reduced dramatically and the commercial viability should be increased in the future. Okay, so that's a great thing about the technology. Fine. Okay, these are the, you can further look into these excellent areas, some of the upcoming devices. Okay, and thank you for listening. Thanks for the opportunity. This is my contact number, and you have your Q